289 and page 290. Let's choose another problem with same degree over same degree, and then we'll look at the other two. Bless you. So please choose a problem between 41 and 64. On page 290 that has same degree over same degree. Uh, 56, correct. Very good. 56, they say r of x equals 4x squared divided by x squared minus 2x minus 3. Once you give me this function, you ask me to graph it. What do you think will be the first thing I do? Yes. How do I factor it? The product is -3, the sum is -2. Very good. So now I can start my chart. What is the domain of this function? I'm kindly asking you to use this weekend and review everything for the test. Everything we've covered, all problems we covered in class. If we did problem 20, please do 19 and 21. All quiz problems and homework. So we can get a head start and review on Monday. So the domain of this function. Excellent. If you remember the last item, item number 8 last time, that I couldn't remember for a second, or 2, or 3. First of all, when I identify the domain of this function, I have to ask myself, do I simplify x plus 1 from the denominator with an x plus 1 from the top? And the answer is no, there is no x plus 1 at the top. Then I'm asking myself, do I simplify x minus 3 from the bottom with an x minus 3 from the top? No, because there is no x minus 3 at the top, which means these two are vertical asymptotes. If I do simplify, for example, if there is an x plus 1 at the top and I do simplify it, that will be an open point in the graph. It will not be a vertical asymptote. If the factors in the denominator stay in the simplified form, I cannot further simplify this, this is it, then they are vertical asymptotes. If I simplify one of them, or even both, with some factors at the top, the same factors at the top, then there will be a hole in the graph. Okay. So since I know that these are vertical asymptotes, I would like to determine the sign to the left and to the right, to the left and to the right of these asymptotes. I will be using negative 1.1, negative 0.9, 2.9, and 3.1. As you notice, I did not put these points in the chart. They're up there. I'm going to use them and then forget about them. I'm not going to plot anything like that. So one more time, let me remind you, why am I doing this? Since the function is undefined at 3, and that factor doesn't go away, the function has a vertical asymptote at 3. What does that mean? From this side, the function goes to infinity, or, not both, or to negative infinity. I want to figure out if it's this or if it's this. And this number, by plugging it in, will give me that symbol. Positive infinity or negative infinity. Similarly, on the other side, it goes to positive infinity or negative infinity, not both. Okay. So when I plug in, first of all, at the top, I hope you agree, in this, I will not plug in anything. I will not waste my time. Would you agree? Because it's 4x squared. So I plug in negative 1.1, negative 1.1 here, and negative 1.1 here. This will be what sign? And this will have what sign? Negative 1.1 plus 1. So then the product will be, so positive infinity. Now I plug in negative 0.9. Negative 0.9 minus 3. Negative 0.9 plus 1. So then the product of negative and positive turns out to be good. Now with 2.9, 2.9 negative, 2.9 positive, the sign. So 2.9, this is negative. 2.9 minus 3 will be negative. 2.9 plus 1 will be positive. Sign of negative times positive. Very good. And with 3.1, this will be positive, this will be positive, the sign. Very good. Now I would like to determine the x-intercepts. How do I determine the x-intercepts for any function, including this one? Very good. I said y equal to 0. When is a fraction 0? We do know when it is a fraction 0. We do know that, I'm sure. Right?
Numerator 0.
Good. So the numerator is 4x squared. Divide both sides by? Good. So we get x squared equals 0. How many solutions? And what is the solution? X equals 0. How many times? What is the multiplicity?
2.
2. What does that mean? Multiplicity 2 means? Very good. Multiplicity 2 means a term. Excellent. I would like to determine the end behavior now. So if I plug in for the y-intercept, I have to find f of 0, but I know it's 0. I already have it. F of 0 is 0. Good. How do I determine the end behavior for a rational function that has same degree over same degree? How do I determine that? I divide the leading coefficient by the leading coefficient. If you remember, we did that last time. 4x squared. I factor out the degree in the denominator. I get x squared. 1 minus 2 over x minus 3 over x squared. I simplify. The numerator approaches 4, and there is nothing else. And what about the denominator when x approaches infinity? What does this approach? Remember my silly example? I have a piece of paper, and I want, yes? What about 3 over x squared? What does that approach? Good. So then the denominator will approach what? How much is 1 minus 0 minus 0? 1. So then the entire function will approach leading coefficient over the leading coefficient. So y equals 4 is the horizontal asymptote. 4, 4, y equals 4 is a horizontal asymptote. Okay, that's really all I need. This function cannot be symmetric, and I will make a note of that. So that's one of the items on the list. F of negative x does not equal f of x, and it does not equal negative f of x. Not symmetric. I didn't really plug in -1, but a function with a vertical asymptote at -1 and at 3 cannot be symmetric. So now let's give it a shot. Okay, so I'm reading my chart. Before I do anything, anytime I graph a function with asymptotes, I must graph the asymptotes first. So there is a horizontal asymptote, which is y equals 4. There is a vertical asymptote, which is x equals -1. And one that is x equals 3. And now I look at my chart. Okay, here's what my chart says. From approaching 4, go to positive infinity on the left-hand side of the asymptote. From approaching 4 to infinity on the left-hand side of the asymptote. No problem. In the middle, from -infinity, come to the origin where you have to turn and then come back to -infinity. Not a problem. From approaching positive infinity, come down to 4 as x approaches infinity. So this is f of x, 4x squared over x squared minus 2x minus 3. Any questions? Any questions? Okay, so now let's look at type 2. Type 2 is very, very similar. Can you please choose a function with a higher degree in the denominator? So remember, type 1, same degree over same degree, whatever it is. Degree 2, degree 2, degree 1, degree 1, degree 3, degree 3, degree 3. Type 2 is a rational function with a higher degree in the denominator. So please choose. There is only a minor difference from the previous one. I would like to choose 52 with your permission. In 52 we have r of x equals x minus 2 over x squared minus 4x. Is this type 2? Is the degree in the denominator higher than the degree in the numerator? Okay, what do you think I'm going to do first? Good. So what do I factor? Good. So I have x minus 4. I'm getting my chart ready. Domain of this function, please. Yes, I jumped because it's the X-Intercept. Perfect. Can I simplify x with a factor from the top that is x? No. Can I simplify x minus 4 with a factor at the top that is x minus 4? No. So then x equals 0 is a VA, and x equals 4 is a VA. Please give me the signs left and right, because if I establish that it's a VA, this has to be infinity, this has to be infinity, this has to be infinity, this has to be infinity. Well, what I don't have is the sign of that infinity. So I can already write infinity, but I do not know whether it's positive or negative. So I will be using negative 0.1 and 0.1 and 3.9 and 4.1. Please plug in negative 0.1 and tell me the sign. What is the sign of the top with negative 0.1? Negative 0.1 minus 2? Negative. Negative. And negative 0.1 minus 4? Negative. 3 negatives. Good. Negative. With 0.1, 0.1 minus 2, the top is? Good. 0.1, x is positive. And 0.1 minus 4. Sign. Perfect. With 3.9, the sign of the top. Perfect. X is positive. And 3.9 minus 4. Good. So the sign is? Perfect. With 4.1, the top is positive. X is positive. And 4.1 minus 4 is positive. So the sign is? Good.
In the previous problem, did we not put the plug-in to the top before x squared?
Because it was always positive, and positive signs will never change anything. I cannot, in x minus 2 could be positive or negative. So I have to plug in everything. Yes. I will not plug in everything as long as I know for sure that it's positive. Yeah. So if I had here in parentheses x to the 4th outside or x plus 2 to the 4th power, I would have not plugged in anything in there.
It was odd how we plugged in.
Yes. And x minus 2 has power 1. Yep. Very good. Okay, I need the x-intercept. How do I determine the x-intercept for any function? I said y equal to 0. When is this fraction 0? When? Yes, indeed, when x equals 2. So y equals 0 when x equals 2. So I have 2, 0. I cannot plug in 0. That would have been my next in line, the y-intercept. So now I only need the end behavior. Of course, this function cannot be symmetric if it has a vertical asymptote at 0 and at 4. Let's figure out the horizontal asymptote. So the function is x minus 2 over x squared minus 4x. What is the degree of the top? 1. So let's factor out x, and please tell me what you get.
1 minus 2x.
Excellent. What is the degree of the denominator? 2. So let's factor out x squared then, if the degree is 2. What do we have left in parentheses? One minus? Very good. 1 minus 4 over x. When I distribute x squared times 1, I get x squared. X squared times 4 over x, I get negative 4x. Perfect. So now I will simplify an x. I'm allowed to because we are talking about infinities. So x, and I get an x here. This is still left in the denominator. And now I'm going to ask you, what does this approach as x approaches infinity? Good. What does this approach as x approaches infinity? Good. So now I'm going to ask you, what does this approach when x approaches infinity? This will be what we have in the numerator. 1. What we have in the denominator. So what does this box approach? 1. However, I have 1 over x. So now I'm going to ask you, what will this whole thing approach as x approaches infinity? So in this box, I only have 1 over x. Nothing else. This is 1. I still have 1 over x. Well, exactly. So please remember, type 2 is easier than anything else. Type 2 will always have a horizontal asymptote y equals 0. Always. Oh, I forgot to show you the first function with the graphing calculator. We'll look at it in a minute. We'll graph both. Okay, now I'm ready to graph. I'm going to say not symmetric. But to be exact, I have to write that f of negative x does not equal f of x, and it does not equal negative f of x. Okay, so I'm ready now to graph. I graph the asymptotes first, mandatory. This function has 3 asymptotes. 2 of them are overkill because they are already there, x equals 0, and the horizontal asymptote y equals 0. But it also has x equals 4. When I graph a function with asymptotes, I have to start by graphing the asymptotes. Start graphing the function by graphing the asymptotes first. Okay, ready? Okay, here's what my chart says. From approaching 0, drop to negative infinity on the left-hand side of the asymptote, of the first vertical asymptote. No problem. In the middle, what does it say? First of all, there is an X-intercept here. So from approaching positive infinity on the right-hand side of this asymptote, come down and cross the x-axis at 2, 0, and then continue to negative infinity on the left-hand side of the next asymptote. No problem. Last branch, from approaching positive infinity down to 0. And this is f of x, x minus 2 over x squared minus 4x. So let's look at the graphing calculator for these two. So in y equals, please don't forget parentheses. What was it? 4x squared, the first one, divided by, in parentheses, what was it? X squared minus 2x, something like that, minus 3. Okay, very good. So I will use the standard viewing window. I go to zoom and then press 6. See what happens. Oh, I forgot something very important. Stop. Thank you. I have to have a second function that is y equals 4. The calculator will not graph it, the horizontal asymptote. Okay, now I'm ready. Okay, so did I plug in everything correctly? Which function did we choose? Minus 2x minus 3. Okay, very good. And then it was, yes, of course, 4. Okay, perfect. Very good. I want to see a little bit here on the left. So I'm going to change the viewing window a little bit to negative 20. Okay. Want to write one note here? I think I mentioned that, but I don't think I wrote it. So, note. A function can cross a horizontal asymptote or a slant. We did not talk about slant. Comma, but never a vertical asymptote. Simply because the function is undefined there. So I have to go back to my graph because there is a correction that I need to make. And here's the correction, not here and not here. The correction is here. Apparently this graph, which we would have not known this without calculus. Apparently the graph does this. Comes from approaching 4, comes down to a particular point where it has a minimum, and then it goes up. Why is that? Basically because the degree is 2 over 2. So in some situations this is expected. So there is a minimum somewhere. We would have not known that without the graphing calculator. So that's why I recommend we always, that's why I'm sorry that I forgot to do that. I remembered that after we finished the second one. So this is the situation. And as I said, it can cross a horizontal asymptote. What is the meaning of this? Nothing in the middle. This means nothing in the middle. So you can, if you want, you can delete it. I'm not going to delete it. I'm just going to make a point. So I can say that the meaning of the horizontal asymptote is just this, right here and right here, at infinities. In the middle doesn't mean anything. But I cannot graph a line showing you a little piece here and a little piece here. So I have to graph the entire line. But in the middle, if the function crosses the horizontal asymptote, that's fine. It's possible. It's allowed. Because really, the horizontal asymptote has meaning only at infinities. But of course, I have to graph a horizontal line so you can see it. But the fact that it crosses here doesn't mean anything. So you don't have to erase anything on a test. Like I'm not going to erase here, or just you can cross it if you want and just show your correction. But we would have not, we don't have enough information in pre-calculus to do that. This will have absolutely no secrets. This function will have absolutely no secrets in calculus, because there we determine the max and the min. We're using calculus, I should say, by hand, not with a calculator. We don't need a calculator to determine the max and the min. So this would have popped up with no problem, but it didn't here because we don't have a tool of determining max min by hand. Good. So now let's look at the other one. So right here, I would like to determine that minimum. I would like to. So I'm going to say second, or put second in calc, and I will determine the minimum, which is item 3. Press enter. So in this case, I see where it is. So I'm going to just go to the left a little bit, make sure I pass the minimum, which I did. So that's enter. I'm going to make sure I pass the minimum. I'm going to press enter and enter again, and it will give us the minimum, which is at -3, and y is 3. So now I go back, and I can write -3, 3, and that's the minimum. Let's look at the other one. So in y equals, clear. You don't have to put the second one as 0, but if you want, you can. This software gives us a second function in red or other colors, so maybe that's helpful. So our function was x minus 2, in parentheses, don't forget, please, x minus 2, and divide by x squared minus 4x. So go to zoom and 6, and let's see what happens. Here comes the function. Right. So the calculator is lying to us. It's very clear. The function doesn't stop here or start here. It doesn't stop here. It goes on forever. It does not give us the vertical asymptotes, but we realize that this is a vertical asymptote, and of course this one is a vertical asymptote 4. And you can play with the viewing window if you want to. So let's say -5 to 5. And -5 to 5. So now this is a better picture, better graph. It's easier to see what's happening, and it's indeed, it goes on forever. It doesn't stop somewhere, so it's continuing up to infinity, continuing down to negative infinity, the same thing here. And it crosses at was 2, I'm sorry. Yes, the vertical asymptote is at 4. Yeah. Very good. So now let's look at type 3. I promise this is the last one. It is slightly more difficult than the previous 2. So please choose a function that is type 3. And those are between 65 and 72. 65 and 72. And then I want to show you one graph with a hole in the graph. One function with a hole in the graph. Okay, I will choose 66. And r of x equals x squared plus 2x divided by x minus 1. Is this type 3? Is this type 3? The degree of the top is exactly by 1 unit higher than the degree of the denominator. So if the top is degree 2 and the denominator is degree 1, when I divide using, in this case, both work, synthetic division and long division, what degree will I get when I divide degree 3 by 1? Degree 2 by 1. When I divide degree 5 by degree 4, what do I get? Which is, in all these cases, it's a line. So degree 10 divided by degree 9, I will get degree 1, which is a line. Degree 2 divided by degree 1, I get degree 1, which is a line. And that will be the slant asymptote. So type 3 does not have a horizontal asymptote. It does not, but a slant. A function that has a horizontal asymptote cannot have a slant. If a function has a slant asymptote, it cannot have a horizontal asymptote. This is just in place of the horizontal asymptote. So let's find the horizontal asymptote first, because that's the only difference from the previous 2 cases. So what I have to do is the slant asymptote is the quotient, only the quotient of the division of x squared plus 2x divided by x minus 1. So let's find the division. Let's divide and find the quotient. Would you like to use synthetic division, or would you like to use long division? Okay. X squared plus 2x and x minus 1. X times what is x squared? Let's go back and distribute, change the sign, and write below like terms. X times x is, so I subtract. X times -1, so I subtract. I don't have anything else to bring down, but I have to ask myself, x times what is 3x? Sign. I'm not changing signs up here. I'm only changing sign after I distribute. Very good. So positive 3. 3 times x subtract, and 3 times negative 1. Yes, it's negative 3, but I have to write plus 3. So that will be the remainder. So can anyone dictate how to write this division? What is the quotient? X plus 3. Plus, what is the remainder? 3 over x minus 1. If you have any doubts, what will you do to check? Just to make sure. What will you do? You will multiply x minus 1 by x plus 3, and you will add 3 to get x squared plus 2x. So x times x is x squared, x times 3, 3x, negative 1 times x, negative 3 and plus 3. These two go away, and I get x squared plus 2x. Only this is what we are interested in. So the slant asymptote is only the quotient. So when the function has a horizontal asymptote, let's say y equals 4, at infinities, the function has to approach y equals 4. Otherwise, you will not have a horizontal asymptote y equals 4 if the function didn't approach 4 at infinities. Now this time, this is x plus 3. It's not y equals 4 or 3 or 5 or 10. No, it's x plus 3. So instead of having a horizontal asymptote, it will have a slant asymptote. And it will have to follow the slant asymptote, like it followed the horizontal one. So what will be the end behavior if I have to graph the slant asymptote, which is aligned with a positive slope? What will be the end behavior then? Negative infinity to, yes, it will follow the slant asymptote. It would have followed the horizontal asymptote, but it doesn't have any. It has a slant. Is that okay? Good. So that's the only difference, nothing else. That's it. So let's create the chart and graph the function. What is the domain of this function? So I'm going to write down here, it's r of x, not f. It doesn't matter. I have to factor the top also. So over x minus 1. So what is the domain of this function? Perfect. Does x minus 1 go away with a factor of x minus 1 from the top? No. Which means x equals 1 is, if it doesn't go away, it's a vertical asymptote. I already have that y equals x plus 3 is a slant asymptote. One more time, what is the end behavior? If this were negative x plus 3, I would have had this line. What would have been the behavior with negative x plus 3? To negative infinity. But it's x plus 3, which has a linear function with a positive slope. So what is the end behavior? Very good. I need to determine the signs. I already know that these are infinities, no doubt, but I don't know the sign. So let's plug in 0.9 and 1.1. In the factored form is the easiest. So what is the sign of the top when I plug in 0.9? Yes. When I plug in 0.9 in the denominator, what will be the sign? So this then is going to be negative infinity. What happens, what is the sign of this expression when I plug in 1.1? Positive indeed. Perfect. Okay, so now please plug in 0 in the function and tell me what you get. The best is here in this form, 0, 0 over negative 1. How much is 0 over negative 1? Perfect. And now I have to find the x-intercepts when y is 0. When is a fraction 0? fraction is 0 when the top is 0 and the top is x times x plus 2 equals 0. So how many options are there? Yes, one option is, yes, -2 and 0. Okay. Doesn't look nice. Ready? Of course, it's not symmetric. We can write that down. F of negative x does not equal f of x and does not equal negative f of x. When I graph a function with asymptotes, I must start by graphing the asymptotes. This function has two asymptotes. Has a vertical asymptote at 1, and it has a slant asymptote that is y equals x plus 3. When x is 0, how much is y?
3.
So 1, 2, 3. I'm going to write this. Okay. Now, when y is 0, how much is x? Perfect. This is the slant asymptote. Okay. Ready? I have to plot 2 points, -2, 0, and 0, 0. So I'm reading my chart. Here's what my chart says. From approaching the slant asymptote towards -infinity, cross at -2, 0. You must turn because you have to cross again at 0, 0 and approach -infinity on the left-hand side of the vertical asymptote. One more time. From approaching -infinity, and it has to be near the slant asymptote, cross at -2, 0, come to a maximum because it has to come back and cross at 0, 0 and then go to -infinity. Now, this is impossible. A function cannot connect infinities. It can do this, but it cannot connect infinities. It has to come to a minimum and then connect infinities, like x squared. So from the on the right-hand side of the vertical asymptote, comes to a minimum, and then approaching the slant asymptote, going towards infinity. So there is a maximum that I have to determine, and there is a minimum that I have to determine. Moment of double checking. So go to y equals, clear everything. Of course, you need 2 functions in there. The second function will be x plus 3. The calculator will not graph it otherwise. Now, we had in parentheses x squared plus 2x and close. Of course, I messed up something. Let me start from scratch because it will give me an error and so on and so forth. X squared plus 2x divided by x minus 1. I already know that I should definitely look at -10, 10, so I'm going to say zoom 6. Here comes the function, exactly what I expected, up there too, and here comes the slant asymptote. The vertical asymptote is missing, however. So I have to determine this maximum. It crosses at -2, 0, and it crosses at 0, 0, and it comes to a minimum because it cannot connect infinities. So I know that this maximum is between -2 and 0, so I go with second and calc. I want a maximum, and it's between -2, enter, 0, enter, enter. And it gives us the maximum I'm going to write it down here. Negative 0.7, comma 0.5. And now I will determine that minimum. I see that the minimum is somewhere between 2 and 3, so I'm going to say 1.5 to 3. So second and calc. This time I want a maximum between 1.5 and 3, maybe 4. Right. I did maximum instead of minimum. Sorry about that. Thank you. Okay. Okay, I can do that. Enter, and then move to the right. Make sure you pass the minimum. Enter, enter. So the minimum is 2.7, is obtained at 2.7, and the minimum value is 7.5, roughly. And this is type 3. Very important applications. I'm going to look at an application right now. But before that, I want to graph a function with a hole in the graph. Like I'm going to change 60. So I'm going to do 60, but not exactly 60. So here's a function, f of x squared minus 3x over x squared minus x minus 6. And this is really the end of chapter 3. But I want to look at a word problem in a minute. Very good. So I look at this problem, and I realize right away that what? Which type is it? Because it's very important. Type 1, what are the differences between these 3 types? Type 1 has a horizontal asymptote, leading coefficient over the leading coefficient. Type 2 has the horizontal asymptote, which is always 0. And type 3, not a horizontal. Okay, so which type is this? Yes, so I already know the horizontal asymptote. I could. Okay, so first of all, let's start by simplifying and factoring first. So the denominator is x minus 3 and x plus 2. The horizontal asymptote is y equals 1 over 1. But let's start like we always do, with the domain and so on and so forth. I have to state the domain before I simplify. I have to state the domain on the raw function, because this is the function that I'm interested in, or to graph. So the domain of this function, and let's put it already in the chart, is what? What will it be? Negative infinity to negative 2. Very good. Absolutely. But now I have to identify which of these two, or maybe both, or none, is a horizontal or are horizontal asymptotes. Which one is a horizontal asymptote? See, now at this point I can simplify this, and the simplified form becomes this. The factor in the denominator that is still left and does not go away, that one is a vertical asymptote. So x equals negative 2 is a VA. However, the factor that disappears is not a vertical asymptote, but it's an open point in the graph. So x equals 3 will be an open point, not a vertical asymptote, because that factor goes away. That was my number 8 on the list. Your book doesn't say that, and it should. That should be listed in there, but it's not. Okay, now can anyone tell us what to write here and here, here and here. Careful. These two cannot be infinities. It's an open point. So imagine this is the function, and there is an open point here. Somewhere you see here an open point. So left and right have to be a number. Like, I don't know, 5 and 5. Same number. Because this is the graph, it has a hole in the graph. Now here, the sides have to be infinities. I don't know which one. So here, this is absolutely the case. Here, I plug it in and I come up with a number. So when I plug in 3, because I cannot plug in 3 in the original function, can you plug in 3 and tell me what to write on the left-hand side? We are plugging 3 in the simplified form, and we put a number in here. Very good. We're still plugging in the same thing, so it has to be 3/5. So the open point will be 3, 3/5. Open. Not a vertical asymptote. Okay, so now let's plug in -2.1 and -1.9. And please give me the signs of those infinities. What is the sign of this infinity? Very good. Because it's -2.1 over -0.1. Perfect. Now let's plug in -1.9 and -1.9. Negative, I agree. Okay, now I want the horizontal asymptote. I know that this is type 1. It has a horizontal asymptote. What is it? Leading coefficient, here or here, doesn't matter. Leading coefficient over leading coefficient. 1. So y equals 1 is a horizontal asymptote. Please plug in 0 in this function now. If you plug in here, it's still the same. Plug in 0 and tell me what you get. Very good. Is this function symmetric? If it has a vertical asymptote at -2 and a hole in the graph at 3? No. But I would like to write it mathematically. I should say f of x, I'm sorry, -x, does not equal f of x, and it does not equal -f of x. Not symmetric. Okay, I'm ready to graph. When I graph a function with asymptotes, what do I have to graph first? The asymptotes. So there is a horizontal asymptote at 1. And there is a vertical asymptote at -2. And there is an open point in the graph at 1, 2, 3, and 3/5 is 0.6. And there is an X-Intercept 0, 0. So let's look at the chart and try to make sense of all this. From approaching 1 at -infinity, it goes up to infinity on the left-hand side of the vertical asymptote. No problem. On the right-hand side of the vertical, it's coming from -infinity, crosses at the origin, goes through this point but not quite, and then approaches 1. So from -infinity, crosses at 0, 0, and then encounters that point, it jumps over it, and it approaches 1. So this is the function f of x, x squared minus 3x over x squared minus x minus 6. Now I want to show you that the calculator will lie to you, or to us. So let's punch it in. The second function will be 1. And the first function is, in parentheses, x squared minus 3x divided by x squared minus x minus 6. And I'm going to use the standard viewing method. Good. Good, as expected. And now the horizontal asymptote at 1. Thank you. As you see, there is no hole in the graph. But if you go back to second and calc, and you plug in 3, and I'm sorry, second and table, and you plug in 3, what do you think you're going to get? Of course, it's already here. Although the graph did not show that. Very good. Any questions? Yes,
The
Steve?
other thing I was a little confused was finding horizontal asymptotes and fully get how to do that.
You don't have to do anything. I wanted to show you how we got those numbers.
Well,
Or 0.
Even with the type 1 and type 2 problems, we did those and went through and figured out all the horizontal asymptotes. I didn't follow that.
You want to do another one to find?
If we could.
Sure. So for example, however, I'm not asking you to determine that. I'm asking you to remember, if possible, after we determine it. I'm not going to ask you to show it in writing. Type 1, by definition, horizontal asymptote is leading coefficient over leading coefficient. Type 2, by definition, y equals 0. And type 3, whatever you get, I don't know. So now if I look at a function like, for example, let's say f of x equals negative 3 x cubed plus 1 over 4 x cubed minus 2x plus 1. Sorry about that. So let's say I have this function. What is the horizontal asymptote? Exactly. Now let me show you how we get that. Okay, although this is part of calculus. We don't really need to do this here, but I really don't like asking you to memorize that much. Okay. There are a few things that we had to memorize with trig, if you want, to make our life easier, but here's how we do it. What is the degree at the top of the top? Right, so I have to take out x cubed, the degree, whatever it is. So here you get negative 3 and plus 1 over x cubed. Is this okay? The degree in the denominator is also 3. So I have to factor out that degree. If it were 2, I would have factored 2, but of course I get into a different situation there. So this is 4 minus 2 over x squared plus 1 over x cubed. I hope you allow me to simplify because we're not talking about 0. We're talking about very far away. So x is not 0. I don't have to write x not equals 0 because otherwise I can't simplify, right? So here when I simplified by x minus 3, I already wrote that x cannot be 3. Otherwise I wouldn't be able to simplify. Here I don't have to write this because we're talking about infinities. Of course, when I'm talking about infinity, x cannot be 0. It's infinity, right? Or negative infinity. So where does this go as x approaches infinity? Okay, I have a piece of paper, and I want to share this piece of paper with everyone on the planet. And 10 years from now, I'll knock on your door. How much will you get from it? Nothing. So 1 divided by huge is 0. So what about 2 over x squared? What about 1 over x cubed? So if these are all 0, then what will the function approach as x approaches infinity? Negative 3 over 4. That's how we get it. But this is the concept of a limit, which we deal with in calculus. I'd like to look at a word problem. On page 290, let's look at 85, because it's a very important type of problem. A lot of effort was put in this function, tremendous effort, doctors, pharmaceutical products or pharmaceutical companies, nurses, all medical staff, I should have said, patients, before they found this function, a lot of effort was put in. Okay, so let's read it. A drug is administered to a patient, and the concentration of the drug in the bloodstream is monitored. At time t greater than or equal to 0, of course, in hours since giving the drug, the concentration in milligrams per liter is given by this function. A lot of effort went into this function. Graph this function with a graphing device. Okay, fine. What is the highest concentration of drug that is reached in the patient's bloodstream? We will find this after we graph the function in a minute. What happens to the drug concentration after a long period of time? So we'll answer to part A in a minute. What happens to the drug concentration after a long period of time? What does that mean? After a long period of time, as x approaches, or t in this case, as t approaches infinity. Well, it's not possible, but that's what it means. So look at the function, identify its type, and you will know what happens at infinity. What is its type? Is it type 1? Is it type 2? Is it type 3? 2. So what is the horizontal asymptote for all type 2? 0. Thank God, right? The concentration of this will flush. So we will come to 0, right? Or approach 0. Yes. And how long does it take for the concentration to drop below 0.3? Well, I have to calculate that. So we answered only part 2. So what happens to the drug? So let me start from the beginning. So this is 85 on page 290. So we have C of t, which is 5t over t squared plus 1. And we'll graph the function in a minute. So let's do that, just that. So I have t. I have C of t. In this case, the domain of this function is from 0 to infinity. I'm specifically told this is time. It cannot be negative. So it's greater than or equal to 0. It's even given in the problem. Very good. So I know when t is 0, how much is this function? Good. And when t is infinity or approaches infinity, we just said that. 0. So y equals 0 is the horizontal asymptote. I don't know what happens in between. That's why they're asking us specifically to use a graphing calculator. I'm assuming the function, of course, it has to do something like this. I don't know. I have not graphed it. We just picked the problem. So since it crosses at 0, 0, and this is the horizontal asymptote, it must do something like this. Maybe it does something like this. I don't know. But it has to come to a maximum because it starts at 0 and it comes back to 0. So there must be a maximum somewhere. And it makes sense. You take an aspirin. From having 0 aspirin in your bloodstream, you have to get to a maximum of aspirin in your body, in your system, your bloodstream, and then it will fade away. So there must be. We haven't seen this function, so let's take a look. So clear. You can put 0 as the second function. And the first function is, in parentheses, 5x divided by x squared plus 1. Any questions so far? So I will change the viewing window because I don't need to see the left-hand side, and I don't need to see the negative side also. So 0 to 10 is fine, and 0 to 10 is fine. So let's graph. Good. So as expected, it started at 0, 0 at the origin because there is no medication in the bloodstream of this patient when he is admitted to the hospital. And it has to come to a maximum, and then it will fade away because we know the horizontal asymptote is. So sorry. And it will fade away because the horizontal asymptote is y equals 0. So they're asking us, because in pre-calculus we cannot determine that maximum by hand. In calculus we will be able to. So somewhere between 0 and 3, the function has a maximum. So second in calc, and I want a maximum between 0 and 3. Just give me the maximum. It turns out that it's an hour after that, and it's 2.5 milligrams per liter. I could have not determined this by hand in pre-calculus. No way. Okay, so here is the function. Okay. So our first question was, what is the highest concentration of the drug that is reached? So that's 2.5. That's the highest concentration. What happens with the drug concentration after a long period of time? It fades away. The horizontal asymptote y equals 0. And part C, how long does it take for the concentration to drop below 0.3? So how do I determine part C? How long does it take for the concentration to, first of all, be 0.3?
Set C to 2.3.
Very good. So I have 5t over t squared plus 1 equals 0.3. So I know that this is 2.5. 0.3, let's say, is somewhere here. This is not a horizontal asymptote. I'm just saying this is y equals 0.3. So it goes up to 2.5, and it's from this point on. From this point on, the concentration will drop below 0.3. But I have to determine this point. What t is needed for that? Okay. How do I solve this equation? Here's a hint. Good. So 5t equals 0.3 t squared plus 0.3. What type of equation is this, and what do I do to solve for t?
Subtract 5 to the size.
Yes, I have to move everything to one side because it's quadratic. So 0.3 t squared minus 5t plus 0.3 equals 0. What method will I use now for solving quadratic equations?
Use quadratic.
Of course. So t equals negative b plus or minus b squared minus 4ac over 2a. So left parenthesis, 5 plus the square root of 25 minus 4 times 0.09. Close. Close the outside. And now divide by 0.6. And the other one, which has to be right there before, because it crosses twice, right? We know that. Okay, so here's what I got. This moment right here, which is not what we are looking for, this is 0.06. But this point that we are looking for is 16.6. So coming back to the question was, how long does it take for the concentration to drop below 0.3 milligrams per liter? So, and the time is given in hours. So after over 16 hours, the concentration in the bloodstream will drop below 0.3 milligrams per liter. So this is a typical situation in which we use rational functions. Any questions? Any questions? Now you have absolutely everything to prepare, ready for you to prepare for this test. So we will have one more homework, and if possible, I would like to get the homework on Monday instead of Wednesday so I can post solutions. So the questions will be from, I don't remember what was the homework for today, but I don't think I put in rational functions. Of course not, I did not. So some rational functions you'll have for Monday. Any questions for me? Can you please review everything between now and Monday so you can come back with a list of questions? So this is test 3, and we have test 4 coming up after that. Did we make up the entire, we had to make, we did make up the whole thing, or just one? I think we made up 2 hours, right? We met twice, 2 Wednesdays, right? Okay.
It was like a Wednesday and a Monday.
Okay.
Or because I had a lab on those days.
Yes, but I think we canceled that and we met on Wednesday. No, we did not. So we did not meet the second time. We did not.
Yeah, I thought we did, because I remember.
I thought we did. Yeah.
Yeah.
Okay. Okay. Well, if we need to meet another time, I always offer a review for the final exam to my students, an extra meeting. So we will definitely have that.